Hey y'all, welcome to week 8. We have made it almost through 8 weeks of digital learning. This week we are going to be looking at statistics, and we did most of this lesson in probably the week or two right before spring breaks. This is one of the last few things we covered at the end of the year, so we're going to review a little bit of this right now. First thing I want to talk to you about is how to do a couple of different numerical analysis. So here we have a data set, and these are actually grades on a math test. So the first thing we want to do before we do some sort of numerical analysis is we want to put these grades in numerical order. Okay, so we want to start with the lowest, and the lowest value here looks like is a 40. And then moving up, I'm just going to cross them out as I get to them, make sure I cover everything. Looks like there was a 59. And then in the 60s, there was a 65 and a 68. And then in the 70s, a 72 and a 78. And then for the 80s, it looks like 2 88s. And then a 90, 99, and 91. And then the highest one is a 100. The main reason I am doing this is I'm going to do a couple of calculations like median, Q1 and Q3, which are positions. And to find a position, I need it in numerical order first. Okay, so now we have a numerical order. Let's talk about some of these different things we can find. First of all, let's talk about mean. Now, mean is just the average. And to find the average, we're going to add all these numbers up. I just realized we are missing 2 numbers. There should be an 88 right there and a 99 right there. Sorry about that. So we're going to add all these numbers up and divide by how many we have. So we're going to say 40 plus 59 plus 65 plus 68 plus 72. And you can be doing this on your calculator. Plus 78 plus 88 plus 88. Plus 90, plus 91, plus 99, and run out of room, plus 100. So the average, you add up all the numbers and you divide by how many you have. Well, we have 12 numbers here, so we're going to add all that up and divide by 12. If you add that up on your calculator, you're going to get 938, and if we divide 938 divided by 12, it's going to give us 78.1666, and it's going to go on for a while. Let's just round this to the nearest hundredth, so that'll be 78.17, and that's the average. The median is the number in the middle. Okay, so it's very important that we have these in order. And so here we have 12 numbers. The middle would be where I have 6 on either side. So if I count 1, 2, 3, 4, 5, 6 from 40 to 78, that's in the first half. And then 88 to 100, that's in the second half. Okay, well here, when I have an even number, the middle is not falling on a particular number. It's between 2. If that happens, if it's an even number where you split it evenly and there's no one single term in the middle, we're going to have to find the number that would fall between those 2. That is what's right between 78 and 88. So you can either think, okay, let's count down and figure out what's right in between, or you can just average the 2 numbers. And remember, to average, we add them up and divide by how many we have. And so 83 is what's right in between those 2. That's your median. So the median is the middle number, split in half. And if it happens to be 2 numbers, average them together. The mode is the one that occurs the most. So occurs means happens the most. If we look at this, there was only one number that happened more than once, and that was 88. So 88 is our mode. The lower extreme, this is also called the minimum. This is just your lowest number. Very easy to find, 40. The upper extreme, this is also called your maximum. That's easy to find as well. Highest number is 100. The range is the difference when you say the maximum minus the minimum. This is a measure of spread. This tells us how spread out the data is. Now, when you find the range, you don't just say from 100 to 40, you actually do the subtraction. The maximum was 100, the minimum was 40, so the range here is 60. There was a range of 60 points on these math tests. The lower quartile, Q1, the quartile, remember quartile, think quarters, we are dividing the data into fourths. So if you're at the lower quartile, Q1, you're at the 25th percentile. That means it's where 25% of the data is below that point. The way we find this is it's actually the median of the lower half. Now, the lower half occurs below the median. So the lower half here, let me switch colors real quick, would be everything on this side. So the median of these 6 numbers on the left side would be Q1. Well, if I find the median, the number right in the center, if I split 6 in half, that gives me 3 on one side and 3 on the other. Again, it's falling between 2 numbers, so I've got to add them together and divide by 2. And Q1 is 66.5 because it happened to fall between 2 numbers. The upper quartile is the 75th percentile. And this one we find by finding the median of the upper half. So I'm looking at everything on the right side. Again, I've got 6 numbers. If I split them in half, it's falling between 90 and 91. So I'm going to add those together and divide by 2. So 90.5 would be the median of the upper half. Now, the interquartile range, remember range is just the difference between 2 things. Regular range is the difference between the maximum and the minimum. Interquartile range is the difference between Q3 and Q1. This is also known as the middle 50%. And the reason why it's known as the middle 50% is, remember we just talked about, these are quartiles. These quartiles are dividing my data into quarters. A quarter of the data is from the minimum to Q1. So we have a fourth of the data here. A fourth is here, a fourth is here, and a fourth is here. I have 3 terms in each one of these. So if I'm talking about from Q3 to Q1, that's this middle section. That's the middle 50%. So Q3 is 90.5. Q1 is 66.5. And if we subtract those, then we get that the middle 50%, the interquartile range, IQR, is 25. Okay, now that we've done some numerical analysis, let's actually read some graphs. First graph we're going to talk about is a box plot, which is also called box of whiskers because it looks like you have a box with whiskers extended. As you move on, you'll just hear them called box plots. But let's go ahead and the first thing they want us to do is to label the 5-number summary on these box plots. In order to create the box plots, you had to know the minimum because that's what you put right here. What this graph is showing is the points scored for 2 basketball teams. So Team A's minimum points scored is 30. Team B's minimum points scored looks like it's 40. Another number you're going to use in the 5-number summary is the maximum, and that's going to be the highest point on our whiskers. So Team A made 70 points for the most points, while Team B, since it's right between 60 and 70, it looks like they made 65. The other 3 numbers in the 5-number summary that we use for the box plot are Q1, the first quartile, the median, which is the line in the middle of the rectangle, and then Q3. So Q1 is the first line in the rectangle, median is the line in the middle, and then Q3 is the last line in the rectangle. All right, so our second question said, which team had a higher median? Well, the median is right here for Team A and right here for Team B. So even if I don't even look at the values, I can say Team A's median is higher than Team B. When it says which team had a lower lowest extreme. So our lowest extreme, our minimum is down here. Team A is down here at 30, Team B is at 40, so Team A would have the lowest lower extreme. Number 4 says, what percent of the data for Team A is above 60? Well, 60 is found right here. So for Team A, that's at the median. Remember we called the median the 50th percentile? So if I'm talking about what percent is above this, well, 50% should be above it and 50% should be below it, right? So for 60 for Team A at the median, 50% of the data should be above that point because for Team A, that's the median. Number 5 is asking about the same value, but for Team B. Well, notice 60 is not at the same position for Team B. For Team B, that's at the 3rd quartile. Okay, so that's at Q3. Well, we talked about Q3 is at the 75th percentile. That means 75% is below that point. But notice it wants to know what's above. Well, if 75% is below, what has to be above? 25%. So recognize that each one of these segments is 25%. 25% from the minimum to Q1, 25% from Q1 to the median, 25% from the median to Q3, and 25% from Q3 to the maximum. Okay, let's talk about a stem and leaf plot now. So the first thing you're going to notice on a stem and leaf plot is the key. Down here at the bottom, the key tells us what the stems and leaves represent. And that's our first question here. So looking at this, since it says 6/8 = 68, that's telling us the stem, which is 6, is representing the tens place. And then the leaves, which is represented by 8 here, is going to be the ones. So that's important to notice first. Now, number 2 says, what's the lowest score on this test and what's the highest? With a stem and leaf plot, it will always be in order. So it looks like the lowest score we have here is 68. And the highest score we have here is 97. Notice 92, 96, 96, and 97. 97 is the highest score. How many students made a C? Well, a C would be in the 70s, and I would find the 70s right here. To figure out how many students are represented, I'm counting how many leaves. Each leaf represents an individual. Well, in the 70s, one person made a 75, one a 77, and one a 79, so that's 3 students. Which grade occurred the most? Now, I'm asking A, B, C, D, F. Which one of those occurred the most? Well, you can look at this and see which one sticks out the most. Well, that's going to be your 90s, which is an A. And you can count it up. There were 4 people who made an A, which is the highest. And then the last question, how many students made less than 80? Well, 80 is right here, so less than 80 would be everything below 80, which we're counting the leaves because the leaves represent individuals. 1, 2, 3, 4 students made less than 80. All right, last thing we have here, we have a histogram. And so the first thing it asks is how many cherry trees were measured? Well, I can figure out how many are in each bar and then add them up. It looks like there were 3 trees in the first bar, 3 in the second, 8 in the third, 10 here, 4 and 2. And so if I add those numbers up, that tells me there were 30 trees total. How many trees were at least 80 feet? Well, here's 80 feet. So from 80 and up, there were 4 in this bar and 2 in this bar. That's 6 total trees. Number 3, can you tell how tall the shortest tree was? Well, not really, but I can tell where it is. I know the shortest tree is somewhere between 60 and 65 feet. So no, but I know it is between 60 and 65 feet. And then the last question, how many trees were less than 70 feet? Well, here's 70, so less than 70 is going to be here, and I got 3 in that and 3 in that. That's 6 trees again. Okay. All right, so read over this. You're going to have some practice with these same types of graphs. Feel free to pause as you need to. I know I rushed through some of these a little bit quickly, and as always, you could message your teacher on Teams to ask questions. Please have your assignment turned in by Friday at midnight. Check your grades on Focus. Grades should be pretty much updated at this point, and make sure that you aren't missing any assignments from previous weeks. This is a great week to get caught up and finish those assignments up. Just let us know if you finish them up so we can go back and check them and give you your credit. Have a great week. Talk to you later.